Hi guys, please subscribe, like and comment on the video below. Still we're talking about transmission lines. The block diagram there illustrates how a transmission line network is represented on the block diagram. We have a sending end side, we have the transmission line, we have the receiving end side. So now today we're going to talk about the short transmission line equivalent circuit. TL stands for transmission line. So equivalent circuit. Okay, we will be analyzing this short transmission line equivalent circuit using an ABCD two-port network. ABCD two-port network. Okay, what this does is writing the equations of the equivalent circuit in a matrix form using the constants of ABCD. So from the equivalent circuit, that's where we're going to abstract the equations and write the equations in a matrix form. So the equivalent circuit of a short transmission line consists of a resistor and an inductor, then the receiving end part. So this will be IS on the sending end, it will be VS on the sending end. Okay, at this point I'm sure we all know that the equivalent circuit are written in a single phase diagrams. So we have a resistance of the line, we have inductance of the line. On here on the receiving end we have IR, this is the receiving end, we have VR, voltage at the receiving end. So we can clearly see on this diagram that we have these two combinations, which is the resistance of the line, inductance of the line, as the impedance of the line. Okay, so Z line, this is how you write the impedance of the line. Z line consists of the RL, which is the real part, and the imaginary part, XL. It stands for line. So that's that impedance of this equivalent circuit. Now what we want to write in the form of a matrix is the sending end current and the V sending end voltage. So since it's in series on a short transmission line, the capacitance, the shunt capacitance, is insignificant. It's very small, so it could be negligible. So in the calculation basis, we are neglecting the capacitor. So now we take this equivalent circuit as a series circuit. So in a series circuit, now we know IS is equal to IR. Okay, that's the first equation. Okay, IS is equal to IR. So what is VS? What is V sending? So V sending will be this voltage drop caused by this impedance here, impedance of the line, plus the receiving end voltage. Okay, so this voltage drop will be IS times the impedance. Okay, So Vs will be equal to Is times Z line plus VR. VR. We are doing in terms of voltages. This is the voltage of the line, a voltage drop on the line. We are writing this. This is actually the Kirchhoff voltage law. The sum of the voltages should be 0. Okay, so now we know that Is is equal to IR. So now we're going to substitute in the place of Is, IR. So we're going to be having IR Z line plus VR. Okay, so coming into the matrix form, the ABCD matrix form, the how it's constructed for the questionnaire, you have to calculate ABCD. So it's written in this following. So it's going to be Vs, Is equals to A, B, C, D, right? On here it's going to be VR, IR. Okay, so if you break this down in terms of if you multiply out, you want to take it back to the equations, you can say just Vs equals to the VR times A. It's going to be A VR, then IR times B is going to be plus constant B times IR. Okay, so this is the first equation for sending end voltage, and then the sending end current will be Is equals to VR times C. So it's going to be CVR plus IR times D. It's going to be DIR. So this is what you want. This is the desired that you want. So these constancies are the ones that are normally asked on a question. So calculate the constancies of ABCD for the two-port network. So now it is the constancies of VR and IR for both equations. So now we had this equation, Vs equation, we had equation 1, second equation. We have equation 1 for the short transmission line, and Is is equal to IR. It doesn't change on short transmission line. We have Vs on short transmission line as IR times Z line plus IR plus VR, plus VR. So now how do we write this in this form? Okay, so we know we have Is and Vs. So we say Vs Is equals to, so now what would we have as A if we could multiply VR to A and give us, okay, so this needs to be arranged. We need to first arrange that. We need to first arrange our equation so that it could suit our statement here. So our Vs will be VR plus IR Z line. Then our Is will be equals to IR, right? So now it's going to be Vs Is equals to, so what is A, the constant A? Do we have VR on the equation? Because it's going to be VR times A. We have VR on the equation, so we're going to have to multiply to 1 to get that VR. So we have to put 1 in the place of A. So A is equal to 1. So what about B? IR times B. So now on the equation we have Z line, so meaning that on B we're going to have Z line here. So B is equal to Z line on the short transmission line. So what do we have now? We have finished with our first equation, so it's going to be VR IR. If we multiply back to the to this equation, we will be able to get this, because it's going to be VR times 1, going to be VR plus IR times Z line is going to give us this. Okay, so now going to IS is this. IS is equal to IR. Okay, so in terms of what will be our C when multiplying VR to give us nothing, because we don't have VR on IS, so it's going to be 0 here. And then now what will be our, because our C now is 0, what will be our D? Our D will be 1, because when we multiply IR with 1, it's going to give us IS equals to IR. So D is equal to 1. Therefore, D is equal to A on the short transmission line. So basically, guys, if you are asked to calculate ABCD two-port network, this is how you do it, and you're able to boil down to these equations. So now, in a sense of the real numbers, if there's the real numbers, you obviously gonna have B as a real number containing a resistance and an inductance, and the VR also will be containing a real number. So now you know the sending end current is equal to the receiving end current. It doesn't change, so it remains the same. So once again, guys, please subscribe to the channel, like and comment below. Thank you.